Welcome to the webinar on MBD Guide to Success. My name is Ron Grover. I'm an application engineer with GoEngineer, and today we're going to be looking at MBD. Whether this is your first time being exposed to it or you're familiar with it, hopefully we can give you, or I can give you some good information, tips and tricks, and give you some good stuff to go on here. So the first thing I want to do is I want to talk about where MBD fits into the SOLIDWORKS product portfolio. As you can see over on the right hand side, there's a section of purple tiles there. This is all the technical documentation and communication tools that are available in SOLIDWORKS. And MBD is a portion of those. So the purpose of SOLIDWORKS MBD is several-fold here. It's going to help us define and organize and publish 3D PMI, and I'll talk about PMI here in just a minute, what that is. It's going to help us to streamline production, cut cycle times, reduce errors, and comply with standards. Those are all good things within a company. Some of our customers, this is going to help them comply with standards like the MIL standard 31000. This is a newer standard that's come out. If you are involved with aerospace manufacturing or military manufacturing, you will be familiar with the MIL standard 31000. MBD helps us comply with that. So let's talk a little bit about the general engineering and design process. You as a designer engineer, let's take for instance this aluminum bushing here. And the typical process of this is you're going to design it in SOLIDWORKS, and you're going to go through a process of creating features. These features are representing manufacturing steps, manufacturing processes. From the SOLIDWORKS model, we're going to create this part here. Maybe we need to face it off. We'll bore out the inside and outside diameters. We'll drill the holes. And we hope to end up with a finished part that represents or that looks very similar to the part that we've got in our SOLIDWORKS CAD system. Now, how do we capture all that information from the SOLIDWORKS CAD system and relay that to the guys out in the shop, the ones actually manufacturing this? Well, right now we use 2D drawings. 2D drawings have been the standard for a very long time. It's been a good reason for that. They've been the only thing that's been available to us. But what happens with 2D drawings is that we are trying to communicate our design intent through this 2D medium. And a lot of times our design intent gets lost. It's not understood all the way. And so MBD attempts to help fix that problem, right? If we make mistakes or if things aren't communicated clearly, it costs us time and money. And the process of producing those 2D drawings costs us time and money. It's estimated that between 30 and 50% of a designer's time is spent creating these 2D drawings. And if we can eliminate that, well, then that gives you back, 30 to 50% of your time that you can use for design processes. So MBD fits into this very nicely. MBD allows us to capture all of that information within the 3D model, which in turn means that we don't have to produce 2D drawings anymore. We skip that step, and it makes this the process of communicating our design intent much easier. So let's talk a little bit about model-based definition. Let's answer the question, what is it? Model-based definition allows us to capture PMI. PMI is product and manufacturing information. This is information such as surface information, weld information, bombs, notes, dimensions, callouts, all the things that we would typically add on a drawing to convey our design intent or the manufacturing processes that are to be used. So MBD will help us capture this. MBD is a part of what we call a technical data package, or TDP. It's a collection of deliverables that defines a part or drawing. So this would be drawings, bill of materials, quality inspection manuals, any sort of documentation that fully defines that particular product. That's called the technical data package. Now, we're not going to talk about that. That's outside of the scope of MBD, but MBD helps us to produce that technical data package. MBD also fits into a larger model or a larger role, and that is the model-based enterprise. MBE is basically when an entire organization is utilizing MBD in the manufacturing process. So this is from design all the way through manufacturing, through inspection, through the end use of the product. Again, we're not going to talk about model-based enterprise. That's outside the scope of MBD, but MBD fits into all of these other areas here. So we capture PMI, we're part of the TDP, and we're part of the MBE. So as I said before, MBD is basically the process of annotating critical manufacturing data. We capture that in a 3D master document instead of on a 2D drawing. There have been many times in my career, I've had a lot of experience as both a designer and a drafter, where some mistakes have been made, and those mistakes can translate into dollars out on the shop floor, right? Time lost, money lost, rework, those kinds of things. These are the things that we don't want to have happen within our companies. So MBD is a way for us to help to minimize those impacts or those effects. And again, it's basically taking, instead of a 2D drawing, we're doing a 3D master document here. So when we talk about MBD, we have to talk about the value to the organization. If there's no value to it, you're not going to use it. What we found is that with MBD, it reduces the effort to produce the PMI, right? So we're spending less time on the manufacturing information. There are less documents to manage because now I'm dealing with just a 3D CAD file instead of the 3D CAD file and all the documentation that goes along with it. One of the nice things about MBD is that you can capture extra documentation within that 3D model file and use it as kind of a package, if you will. It removes the translation of 3D to 2D to 3D. I like to think of the movie Lost in Translation. There's that term out there of lost in translation. Think about it in terms of translating languages. I can translate words, but I can't necessarily translate meaning. And so that's what sometimes happens when we go from 3D to 2D to 3D, is the meaning is lost. So with MBD, that meaning is not lost. The meaning, the intent, the design intent is captured. It also allows us to produce portable delivery methods. These would be things like PDF files, e-drawings files, those kinds of things that are CAD agnostic. So somebody out on the shop floor doesn't necessarily have to have SOLIDWORKS installed. They can open up a PDF file and have access to all of the 3D information that they need to manufacture that part. All of this results in cost savings due to efficiencies and error reductions. And so that's obviously a benefit to our companies. So like I said, value to your organization. There's a lot of value in MBD. If you're not using it currently, hopefully you have plans to use it, and it will help you save time and money. With MBD, we also talk about steps in the implementation of MBD. And these are some of the steps that we've identified and that are out there in industry. Basically, we're going to analyze the PMI consumption, understand the jobs and data needs, plan where you want to end up, define critical manufacturing dimensions with GD&T and such. What I want to focus on today is not necessarily going through the implementation steps, but I want to focus on just a couple of things. I want to focus on, number one, how do we capture that PMI information in the model file itself? And we do that with DIM Expert. We're going to look at DIM Expert in some depth today. And then how do we set up the 3D PDF template requirements? How do we create those templates according to our own company standards? What do we need to include on those? And then how do we create 3D views? In order to accurately or to get a 3D PDF, we have to have 3D views within SOLIDWORKS. And so we're going to look at creating 3D views and some of the things that go along with that. So as far as implementation goes, we're going to be focusing again on these couple of steps here. The last step, obviously, in the process is to roll it out to all the engineers. And so now we'll go ahead and we'll jump over into the software. And we'll take a look at some examples. I'm going to show you kind of where we end up with all of this first, so you know where we're going, and then I'll walk you through the process of getting there. So here's a component. This is part of an arm orthotic device. It's a mechanized device that helps people with non-functioning or low-functioning arms. This is just one little part of it, but you can see out here in the graphics area that I've got some dimensions on the screen. These are dim expert dimensions. So these are dimensions that capture, again, that PMI information, that PMI data. As you can see, not only do I have tolerance dimensions, but I also have GD&T. I've got a center of mass symbol out there. So a lot of information gets conveyed with those dim expert dimensions. If I flip over to the PDF of this document here, we can see that we've got a lot of information here that is normally included on, let's say, a drawing, but now again it's in that PDF format. It's CAD agnostic. I don't have to have SOLIDWORKS to open it up. I'm not creating a PDF of the drawing. And so the first page here has a whole bunch of notes. These are things like standard notes, what materials, when this was approved, what the document number is, what the revision is. So a lot of that general information. The second page here contains some views of the model. So this would be representative of maybe several pages in our drawing. Notice here I've got, again, those dim expert dimensions that are showing sizes, locations, tolerances. Up here at the top, I've got some views here that I can change. And one of the really cool things about this is that built into PDF, again, I'm not using like a full version of PDF, this is the Acrobat Reader, is that I can zoom in and out and I can rotate the model, and I have access to all of that PMI information right here within the PDF file. I can even include special areas for notes. This is an area that can be filled out by somebody on the shop floor, by a customer or vendor, with notes regarding your design. They can actually save that and send it back to you. So the PDFs that are produced from MBD are a very powerful communication tool. And we'll be looking at this process a little more in depth about, how do we create these things here in just a minute. So for the dim expert portion of this, I'm going to start off with a fairly simple part here. With dim expert, there are two methods that we can use to approach creating dim expert dimensions. One method is an automatic method, and SOLIDWORKS will go in and try to automatically apply the proper size and location dimensions, as well as geometric tolerances, datums, those kinds of things for us. Now, oftentimes it does a really good job of doing that. There are some times, though, where we're going to need to manually create those dimensions. So we'll look at both of those operations or both of those processes here. The dim expert tools live on the MBD toolbar up in the Command Manager. They also are available through the dim expert manager here. I've got access to a couple of tools. So the first thing we're going to look at is the automatic creation. The auto scheme. So if I click auto dimension scheme here in the dim expert property manager, I have some settings here. I can tell it whether this part is prismatic or turned, what tolerance type, whether I want plus, minus, or geometric, pattern dimensioning, if I want to dimension those patterns that I've got, and then I select a primary, secondary, and tertiary datum. So I'll go ahead and select a couple of datums here. So there's primary, secondary, and my tertiary will be the bottom here. I can have it dimension all the features or just selected features here. I'll go ahead and let it do all features just to show you what the auto dimensioning scheme does. So I'll go ahead and click the green check mark for OK. And now I've got a whole bunch of dim expert dimensions on my screen with geometric tolerances applied. That was really easy, basically a one-click solution for this. And like I said, it does a pretty good job. There may be some things that I might have to adjust here. The other nice thing is that it automatically applies the dim expert dimensions to the proper annotation view. That is another layer of using dim expert and MBD, is that it works with these annotation views. Annotation views are basically special views within SOLIDWORKS that allow you to put annotations on them. So these are things like, again, dim expert dimensions, notes, weld symbols, surface finish symbols, anything that you need to include either in MBD or even on just a normal drawing, you can use annotation views to capture that information. We'll look at annotation views a little bit here in a minute as well. So now I've got all of my DimExpert dimensions on here, and you'll notice that my part turned green. My part is green because I have an option turned on for show tolerance status. Basically, this functions as the same way a sketch would, whether when you have underdefined, overdefined, or fully defined sketch entities, they're different colors. Same thing applies here. Everything that's in green is fully defined. Anything that would show up as yellow is underdefined, and anything that shows up in red is overdefined. So because we use the auto dimensioning scheme, everything is fully defined. It's all green. We're good to go. And then we can go ahead and move on to the next step in the process. So that's one method of DimExpert creation. The other method is to create these DimExpert dimensions manually. So I'm going to go ahead and delete this scheme, and I'm going to start a new scheme. This time I'm going to use some manual dimensioning techniques. First thing I'm going to do is I'm going to define some datums. So I'll use the datum tool, and I'll go ahead and place a datum on, again, the 3 datum faces that I picked earlier, the primary, secondary, and tertiary. And I've got all of my standard datum properties that I can adjust. And then let's go in and maybe we'll add some location and size dimensions. So maybe I want to add a dimension here for the size between these two planes. So we'll say create a width feature here. There we go. Maybe we'll dimension this cut through here. And maybe we'll create a locating dimension to that one as well. So it's very easy to create these dimensions, very similar functionality to how we would create dimensions in sketches. There are a few additional things that we need to consider when we're doing DimExpert dimensions. Number one is that while they function similar to sketch entities, they are different. And so if I need to create, say, a location dimension that references something that's not here in the model, an edge, something like that. Let's say that I want a dimension to the point at which these two angled faces meet. What I need to do is I need to use this selection toolbar. This is going to help me select additional entities. I'm going to go ahead and create an intersection line between that face and the face on the other side here. And you can see it puts an intersection line out there for me. Now I'll go ahead and select the other entity I want to dimension to, and I can dimension to additional things that way. That selection toolbar will also help me to apply dimensions to things like patterns, axes, those kinds of things that aren't, again, readily available in the model. Now, to move forward, because I don't have a lot of time here, I'm going to go ahead and delete this scheme. I'm just going to do an auto dimension scheme again, just to get the dimensions in place. And so again, we'll pick our primary, secondary, and tertiary. And we'll hit OK. And all of our dimensions are there. Now, the second step in the process of creating some output from this, let's say the PDF is our final output here, is to capture 3D views. These 3D views are what are going to populate the views on that PDF file. To capture the 3D views, I'm going to go down here into these tabs where it says Model, 3D Views, and Motion Study. I'll open up the 3D Views tab. Let me expand this up here just a little bit. There we go. And right now, with where everything is at, I can capture a 3D view. 3D views are similar to saved views, but they capture additional information. With a 3D view, I can capture the configuration that's being used, the display state, as well as any annotation views that I want to apply here. I'm going to go ahead and give this 3D view a name. I'm going to call it ISO. And now that 3D view lives there in the 3D Views toolbar. If I were to produce a PDF straight from here, my PDF would have one view that is a 3D view. And I can even pick and choose views to export to a PDF as well. Let's go ahead and create a couple of additional views. I'm going to turn on an option called Dynamic Annotation Views. This will show me annotations when I'm aligned with that specific annotation view. So if I expand annotation views here, you can see I have front, right, and top annotation views. So when I rotate into a position where I can see the front view or the front of the model, those annotations will come into view. If I go to the top of the model, now only the top annotations are visible. And if I go to the right side of the model, only the right annotations are visible. So we're going to go ahead and capture some of these views. So I'm going to go to the front. We'll capture that 3D view. And I only want to capture the front annotation view here. I'll go to the top. We'll do the same thing. Zoom out here. We'll say capture 3D view. I'll call this one top. And I want to show the top annotations only. And then we'll go to the right side here. We'll capture another 3D view. We'll call this one right. And this one I only want to capture the right in. So now I can go to the different views by double clicking on them. And you'll notice that I only get the DIM expert dimensions that are associated with that annotation view. Now, there is another portion of DIM expert here that I need to talk about, and that is the tolerancing information. Notice how it automatically applies tolerances. These are document properties. So I go into the document properties under DIM expert. These dimensional tolerances are based right now on the ANSI standard. Most likely you will have to adjust these based on your company's standards, but all that information is found here in the document properties. All right, so let's say I've captured all of my 3D views. Maybe I want to change up the order here. This is something that's new in 2017. I can change the sort order of the 3D views. Right now they're sorted by history, so basically the history of when they were created or how they were created. I can sort them by name or by configuration, display state, or I can choose a custom sorting method. Let's try and sort these by name. Maybe that's not the way I want it. Maybe we'll say I want a custom sort. I'm going to move the ISO to the first view. I want that to always show up first in my PDF files. There's a couple of other tips and tricks here that I want to impart real quick. One of those is for the annotations. There are different ways to show the annotation tree here. So if I right click on the top level, go to tree display, I can show them as annotation based, feature based, or the flat tree view, which is actually both of those combined. So this one shows the actual annotations. This one shows the reference information that they are referencing. The default is feature-based, by the way. Now, 3D views also capture, like I said, configurations and display states. I'm not going to capture any of that information here, but if that's something that's required of you guys, you can definitely capture that information. Let's look at the PDF file. So right now, if I click Publish to PDF, I can utilize the generic or included templates with SOLIDWORKS MBD. Basically, I have multi-page and single-page, simple parts, simple assembly templates. These templates are basically represent XML files. I've looked into how to create these templates outside of SOLIDWORKS. It's really not easy to do, if at all. If you're an XML Jedi, then you might be able to figure that out. But to create these templates, we'll stay inside of SOLIDWORKS. We'll look at that here in just a second. To create the actual output of a 3D PDF file, I'll go ahead and select my template first. I've got one that's been built for GoEngineer. It represents a part file. It's in landscape mode. And now I can choose which views to include in the PDF file. I can include primary views. I can also include the 3D views that we've captured previously. So I'll go ahead and select the 3D views that I want to include in the PDF. If I have a large file, a very complex file, I can change the accuracy information here. This basically lowers the tessellation values, makes it look a little more chunky and blocky. similar to the image quality slider in a part document. You slide the image quality down, it looks a little more chunky and blocky there. You can also use lossy compression. This is similar to how a MP3 file works. Throws away some of the information and data there. The other cool thing with these PDFs is I can actually attach files. So if there's additional documentation that needs to go along with the PDF, additional files, I can include the SOLIDWORKS files if I want to, and I can include a step file. There's a new or a newer standard for step files called AP242. The 242 standard actually includes the PMI information with the step file itself as well. So if you needed to take this and send it to a manufacturer or vendor and actually give them the model file for manufacturing purposes, then you can create and include that with this PDF file as well. You can do that post-process here, but it's nice to have that checkbox to just include it alongside of creating that PDF file. So go ahead and hit next here. If I have any custom text fields, I can go ahead and change those. And I'll go ahead and click the green box. We'll give it a name here. You can see I've done this a couple of times, and we'll go ahead and hit OK. It's going to go through, save out all the views, create the PDF file, and then it opens it up for me because I had that option checked. One of the things that you'll run into here is that Adobe has some security protocols that they won't show the 3D PMI or 3D information by default. So you have to actually trust the document before that's able to be viewed. So go ahead and trust the document. I'll go ahead and click on the view area here, and now I've got access to my 3D PDF file. So I can change the views, and again I can send now just a PDF file with all of that information attached to it. Alright, so with the few minutes that I have left here today, I'll go ahead and go into some of the template information real quick. I'll show you how to access that. So in the MBD toolbar, we have the 3D PDF template editor. I'll go ahead and get into the template editor. I can open any existing templates. So when you guys are creating your own templates, you'll go ahead and start with one of the SOLIDWORKS provided ones and make changes to that. If I open that up, I can open any of the, again, those kind of standard SOLIDWORKS included templates. To create new areas, to create new text information, it's as simple as using the tools up here on the Insert tab. I can insert rectangular areas. I can insert text placeholders, generic tables, backgrounds, all of the things that I need to basically produce a PDF that fully conveys the design intent of my part. I can create multiple page PDFs, come down to the bottom and click on the plus symbol, similar to Excel. I've got a new page. Let's maybe throw a couple of things on here. Maybe I'll throw a rectangle on as a border. So we'll go ahead and drag that across. Maybe we'll add some text. We'll add some general note information. And I can even tie that to custom properties. The PDF form field allows that to be filled in by the customer. And then to create an actual viewport for the views, I'll go ahead and create an independent viewport here. And this will now take in one of those 3D PDF views. Once I'm done making those changes, I'll go ahead and save that. And then that's, again, those changes are available next time I am in that or publishing that PDF file. All right, so that is unfortunately all the time we have for today. I was hoping to go into a little more detail, but I think we got some good information there. If you have any questions, please don't hesitate to contact us, and I appreciate you guys watching. Again, my name is Ron Grover with GoEngineer, and I hope you guys have a great day.